Welcome to Ask and Learn.
Okay, so this question asks us to consider the change in entropy in a system from when you boil tea. So, when you let tea cool after you've boiled it. So the tea is cooling, so it's losing entropy, and the air is gaining entropy because it's being heated. So let's see. What exactly does the first question ask? The entropy of the water while it cools. So as the water cools, if it's changing its temperature, then we can say delta S is equal to MC times the log of T final over T initial. And if you go ahead and plug in all these numbers, 0.25 times 4190 times the log of T final over T initial, not forgetting to convert to kelvins from Celsius, which is a mistake that I've made in the past. Then for this delta S, let me just double check my answer. You should get minus 210 joules per Kelvin. And then I'll label that water. And then let's see, what exactly does B ask? Isothermal for your kitchen, so change in entropy of the air while the tea cools. So if it's isothermal, we can use a simpler form of just Q over T. You don't have to use any integration because T stays the same. Temperature of your room probably is not going to change too much. So Q we need to find, but we know that based on general formula for the amount of heat causing something of a certain heat capacity to cool or warm. So MC water T final minus T initial. And so this is the heat that is lost by the this is the heat that's lost by the T, but it's gained to the air. And so since the Q of the water is the magnitude of the heat lost by the T is equal to the magnitude of the heat gained by the cooling process. So they're equal and opposite. So I put a negative here to make this positive. So this Q needs to be positive, right? Because the room is heating up a bit. Great. And so then our numerator, the temperature that it's occurring at is room temperature, which is the same as T final. So if you take all these quantities and plug it into your calculator, you get 232 joules per Kelvin. And then you can get that the change in entropy of the system is just the sum of these two. Let me label this room. Hard to remember all the labels and also go fast. So that's delta S water plus delta S of room. And then with that, you get, let's see, I guess that would be 22 joules per Kelvin. So you have increased the entropy, and that means the process is irreversible.